All right. Good morning, everyone, and welcome to our presentation on the road ahead. What are the next steps for Cassandra Sidecar and the road to the 1.0 milestone? My name is Francisco Guerrero. I'm a Cassandra committer, and I've been part of the community for the past 4 years, being involved in Cassandra and the ecosystem. And I have Saranya with me.
Hi everyone. I've been working with the Cassandra community for the last 6 years, and I've been working on the sidecar and analytics project most of the time.
Yeah, and today we'll be taking you through the journey of Cassandra Sidecar. So from the conceptual origins to where we are now, and most importantly, what it's gonna take us to get to a production-ready 1.0 release that everyone can benefit from. Here's what we'll cover in the next about 40 minutes. We'll start with the fundamentals. What exactly is Cassandra Sidecar and why does it exist? Then we'll do a check-in on where we stand today. Next, we'll dive into the vision and goals for the 1.0 milestone, explore the documentation strategy, discuss infrastructure improvements, look at future features, and wrap up with how you can get started with the project. Let's start with the fundamental question. Why does Cassandra Sidecar even exist? So the reality is that Cassandra, despite being an incredibly powerful database, has historically been hard to operate. And I mean, it's really hard. Think about it. If you have to manage a Cassandra cluster today, you need to master custom non-standard tools like NoTool. You need complex distributed execution frameworks just to run a single command across your cluster. Basic maintenance tasks that require sophisticated automation, and most teams end up building from scratch. And you're juggling multiple configuration file types, YAML, properties, XMLs, and each with their own syntax and quirks. The result is that every major Cassandra adopter, Netflix, DataStax, Apple, you name it, has ended up building some sort of internal sidecar process. They've all solved the same problems, but they've all solved them in isolation with proprietary solutions that don't benefit the broader community. So what is Cassandra Sidecar? At its core, it's built around a simple but powerful principle, a RESTful HTTP API that passes the curl test. So what do I mean by that? If you can manage your database with a simple curl command, then we're not building the right interface. This means that easy integration with any programming language or automation framework and monitoring system. But it's more than just an API. Sidecar provides a common API that understands different versions of Cassandra, so you don't need different tooling for different cluster versions. It operates on faster release cycles than Cassandra itself, which means it can deliver operational improvements and bug fixes without waiting for the next major database release. So think about it. Think of it as a side channel that bridges gaps in Cassandra's operational stories. Architecturally, it's a separate JVM process that's completely isolated from Cassandra's critical path. This means that operations cannot impact your database performance, and sidecar failures won't bring down your database. The architecture is pluggable and extensible, so you can adapt it to your specific operational needs. But most importantly, this represents a consolidation of efforts in our community. Instead of everyone building their own proprietary management solutions, we are creating a shared foundation that benefits everyone. So why does this matter? Operational excellence shouldn't be a luxury that only large organizations with dedicated platform teams can afford. Sidecar aims to provide that zero configuration out-of-the-box experience you get with modern databases like Elasticsearch or Console. From a security perspective, it eliminates those dangerous SSH-based bulk operations that create security vulnerabilities and operational complexity. Instead, you get controlled, allow listed command execution with proper authentication and authorization. And from an operator experience standpoint, you get a standard REST interface that's accessible from any programming language with a pluggable architecture that adapts to your existing infrastructure and workflows. Let's take a quick look at the architecture. It's built on top of Vertex, and Vertex is built from the ground up as a reactive toolkit. At its core, it uses the event-driven architecture with a single event loop per CPU core. It eliminates the overhead of traditional thread per request models. And what makes Vertex truly reactive is it adheres to the 4 reactive principles. It's responsive with fast response times, resilience through fault-tolerant design, elastic by scaling dynamically with load, and message-driven. It uses asynchronous communication patterns. And this non-blocking I/O model allows a single Vertex instance to handle thousands of concurrent connections with minimal resource consumption. It translates into high throughput, low latency, and efficient resource utilization. It makes a perfect case for systems such as Cassandra. Now let's take a look at how a request to Sidecar will flow from the end user to Cassandra. On your left side, you have an operator attempting to perform an stable import. So once the request has been authenticated and the operator request is authorized, Sidecar will find the appropriate handlers that will serve the request. The handler itself will determine the version-specific adapter it will use based on the target Cassandra version. The communication between the adapter and Cassandra is done via JMX or Cassandra natives protocol. It depends on the implementation. So in this case, the operator request is translated to a JMX operation in Cassandra, and Cassandra will serve that request. If any errors were to occur, Cassandra will propagate those to the adapter, and Sidecar will translate them to an HTTP response that the client can understand. Now let's assume that we are running in mixed mode, and we have another request for a different instance. Sidecar will use an adapter that is specific for version 5.0, and this is completely transparent to the user. So no matter what version of Cassandra you are using, the REST API interface is the same, and operators don't need to worry about nuances between versions. And before we talk about where we're going, let me show you what's available today. So this isn't a roadmap slide. These are production capabilities that organizations are actively using today. First, multi-version Cassandra support. Sidecar provides a unified API that works across different Cassandra versions. It automatically adapts to cluster topology changes and maintains resilient operations even when nodes fail. That means you can manage heterogeneous clusters without during upgrades without switching tools. For the bulk analytics, Sidecar fundamentally transforms Cassandra's analytics capabilities by providing a dedicated pathway for large-scale data processing that bypasses Cassandra's traditional query engine. It exposes raw stable data directly to Spark through optimized bulk read APIs. It enables analysts to perform full table scans, complex aggregations, and machine learning workloads at near native file speeds without the overhead of CQL parsing and query coordination. It also enables bulk writes by allowing Spark to generate SSTables directly and stream them into Cassandra, making it possible to ingest massive data sets from data lakes or perform ETL operations at scale. So this architecture effectively turns Cassandra into a high-performance analytical data store while preserving its operational capabilities, enabling organizations to run both transactional and analytical workloads on the same infrastructure without performance degradation. We have enterprise security built in since version 0.1. Sidecar has mutual TLS authentication with certificate hot reloading capabilities. So you can update security credentials without taking any downtime. JOT support for token-based authentication that integrates with modern microservices architectures, and a comprehensive role-based access control authorization with fine-grained permissions that can be scoped down to the table level. And this permissioning piggybacks on Cassandra role-based access control model, honoring role permissions in Cassandra. For data operations, Sidecar has S3 restore capabilities, and live migration support enables zero downtime host replacements, leveraging fast streaming of S tables. The observability story includes Grub Wizard, metrics integration with filtering capabilities, comprehensive health monitoring through native and JMX checks, and data governance integration with Data Hub for schema reporting and lineage tracking. And with that, I'll hand it over to Saranya.
Thanks, Francisco. So we saw an overview of the key features. I'll now go over some of these features in more detail. Starting with bulk analytics, Sidecar enables faster analytics. And through CEP28, bulk analytics library was introduced in the community. It can be used to bulk read and write data into Cassandra. Sidecar supports many of the endpoints that bulk analytics library needs. The reader uses endpoints like schema read, creating a snapshot, and streaming SS tables. It uses the stream SS table endpoint to directly stream SS tables from the disk. And the writer uses endpoints like token range replica, and it also uses endpoints like upload endpoint and commit SS table endpoint. The analytics runs are at least 30x faster with Sidecar. And for more details on analytics, you can refer to Doug Ruler's talk on Cassandra Analytics 1.2. Moving over to authentication and authorization, Sidecar has a strong security story. It supports certificate-based authentication, JOT token-based authentication, and it also supports role-based access control. Looking at certificate-based authentication, it has mTLS authentication support where the client and the server can both exchange certificates and verify each other's identities. Apart from the handshake, Sidecar also does additional checks to verify that the identity extracted from the certificate is trusted. And this is very similar to how Cassandra itself does mTLS authentication. And for this, Sidecar relies on Cassandra's identity to role table, and the list of authenticated identities there is trusted in Sidecar as well. And if an identity is mapped to a valid role, the request goes through. For admin access, you can also configure admin identities in Sidecar, and along with that, Sidecar treats super users, and Cassandra also has admin users in Sidecar. So some of the other features that make mTLS authentication very flexible in Sidecar is it supports auto reloading, and the dynamic reloading is supported for both server certificates and client certificates that Sidecar uses to talk to other sidecars. And it also, the Vertex-based Sidecar client that comes with the project also has support for mTLS authentication. And these features make the mTLS authentication both secure and more efficient. Now let's take a look at what a sample client certificate looks like. Here I have a stiffy certificate. It has various details like common name, organization, validity, and it also has the SPIFFy identity. The SPIFFy identity is included as part of the sign of the certificate, and Sidecar verifies all these details in the certificate, and it can be configured through the YAML. And the identity that is here as part of the certificate is extracted, and the request goes through if it is mapped to a valid role. And the custom certificate validator that can also be configured through the YAML. Sidecar also has support for JOT authentication, including OpenID discovery for token extraction and validation. And there you can also optionally process a role from the decoded token, and this role processing allows for integration with role-based access control. Going over RBAC, With Sidecar being a control plane, RBAC is very important to make sure that users can access endpoints only to those endpoints they have access to. And for role-based access control, Sidecar verifies access at both the endpoint level as well as at the resource level. And its permissioning model is similar to Cassandra as well. And it honors Cassandra's permissions. For stream as a stable endpoint, it checks that if the user has permission, select permission on the table. And it also has support for custom permissions, which is used for endpoints like create snapshot. It checks if the user has snapshot create permission on the endpoint. And Sidecar also has support for feature level permissions. These are composite permissions that in turn expand to the basic permissions. And this is useful for some of the features that Sidecar supports, like bulk analytics, and we have like analytics read direct permission, write direct permission, and we also have the CDC permission. So here is a sample statement of how you can grant permissions, and Sidecar stores the custom permissions in its Sidecar internal key space. And here the analytics read direct permission is granted for a specific key space, which is the cycling key space and a role. And to execute the bulk analytics job, we need the identity extracted from the certificate to be mapped to this role. And this is the overall request flow. Initially, a client request comes in, it goes to the Vertex router, and then the router routes it to the authentication handler, which can be either an mTLS handler or a JOT handler. And the handler verifies the details in the certificates and makes sure that the identity from the certificate is mapped to a trusted role in Cassandra. And once authentication goes through, the request is routed to the authorization handler, and the authorization handler extracts the permissions from the route-specific handler chain and makes sure that the role extracted from the certificate is mapped to this remaining handler chain permissions. And once role-based access control succeeds, the rest of the route-specific handler chain is executed. So we saw how Sidecar secures every request. Now let's take a look at what are the operational capabilities that are currently in Sidecar. So for any operationally better system, we need proactive management, and periodic task framework in Sidecar allows for this proactive management by having like automated background tasks. And there are tasks that run for various operations like health checks, and we have a task for detecting for CDC log cleanup to make sure that we do not have disk space issues when CDC is running. And we also have tasks for like certificate rotation and schema reporting, which is useful for data governance. The periodic task framework ensures that tasks run serially without overlap, and the tasks are also scheduled on Vertex's worker threads so that they do not overload the main request processing event loop threads. And you can also configure the task to run on only the cluster leaseholder. And when we configure it that way, the task will be run on only one of the sidecars for the cluster. And this is useful for tasks like schema reporting, where we want to report the schema only once per cluster. Now, let's take a look at what are some of the existing operational endpoints. This is a sample set. And we have endpoints for node decommissioning. We also have endpoints for starting and starting gossip. And we have endpoints for live migration to migrate data from one node to another. And there is also an upcoming CP to add rolling restarts of Cassandra instances via Sidecar, and this is CP53. Now let's take a look at observability. It is better to manage a system that we can measure, and Sidecar captures comprehensive metrics both about itself and also about the Cassandra instances that it maintains. So for collecting metrics, Sidecar uses Dropwizard metric registry. It captures the server level metrics into a global registry, and it captures the Cassandra instance level metrics that it creates in an instance specific registry. And it also captures metrics that are captured in the Vertex framework itself. And these metrics are useful, like with the Vertex framework level metrics, we get a view into the sidecar service performance, like what's the request throughput and what's the streaming throughput and thread pool usage like. And these metrics can also be filtered based on the need. And the custom filters for the metrics can be configured through the YAML as well. Let's look at some of the different types of metrics that Sidecar captures. So on the server level side, it can capture metrics like how many instances are up or down, and we also have executor pools like that manage these background tasks, and it gives visibility into those thread pool usage, and it also gives us visibility into the resto jobs that Sidecar maintains and into cache metrics. And on the instance side, it captures metrics about the JMX status, native status, and when we do SS table inputs, it gives us view into how many SS table inputs are queued and what's the data size like, and even observability into streaming. So we went over the existing features in 0.2 version. Now let's take a look at what's next for Sidecar. So vision for Sidecar 1.0 release. This is a very high level vision, and it's a community driven vision, and it's not a finalized roadmap. So the key focus areas for the 1.0 release we want is adding support for Cassandra 6.0 when it is released. It helps us make sure that the control plane is in sync with the latest database. Having a functional CDC to Kafka streaming, and this is for real-time live data streaming, and having a unified backup story. And this is important. This is important because when we have a unified backup story, it can give us a unified experience of backup and restore across different environments with pluggable storage backends, and having like cluster-wide API support, and also adding open telemetry integration to modernize the stack or observability stack. And we also want to capture Cassandra metrics via Sidecar to give complete observability, and having dynamic property reloading. So whenever a configuration changes in Sidecar, we want to be able to have Sidecar running without it having to restart to pick up the configuration, and having robust documentation in the Apache Cassandra website. Looking beyond 1.2, it will be best if Sidecar can manage the Cassandra instance lifecycle, manage upgrades. So when we were adding these slides, these points were still in the post 1.2 vision, but the community has already started working on this. And it would also be best if we can schedule long-running tasks like compaction, repair via Sidecar, and also manage like configuration of Cassandra itself with Sidecar. Getting started, and this brings us to an important part of our presentation: how you can become part of the Sidecar community. Cassandra Sidecar is a community-driven project, and contributions are warmly welcome. The project is present in this GitHub URL. You can get started by running Sidecar locally and testing its endpoints. You can also run sidecars in JVM tests that bring up Cassandra instances and test their functionality with Sidecar endpoints. And we also have a CCM-based Sidecar YAML in the project, where you can start a CCM cluster and locally curl the endpoints to test them. And Guerrero recently also included a Docker image which will bring up the Cassandra Sidecar and Spark, where you can run your Cassandra Analytics library and look at how the integration goes. The release artifacts of the project are present here. Again, like contributions are warmly welcome. All the open issues of the project are tracked through Jira's, and this is the Jira link. And you can also file Jira's for like new bugs and any new feature ideas that you have. For architectural discussions and implementation approaches, Cassandra Dev mailing list is the best place. But for real-time quick questions and collaboration, there is a Cassandra Sidecar ASF Slack channel, and you can ask questions and request code reviews. And this brings us to the end of our presentation. We looked at what motivated to create a community-driven sidecar project, and we also took a look at what's the production capabilities that is available right now in point 2 release, and we saw what's coming next. Next is your ideas of how sidecar can solve the operational challenges in your environment. Thank you.
Take questions.
So roles are now aligned between Sidecar and Cassandra.
Yeah.
So if a super user in Cassandra has a cert, they can run no tool assassinate.
So we still don't we have bespoke node tool support.
Okay.
And we still verify like sidecar specific permissions at endpoint level.
So super user for Cassandra will not necessarily have new like no tool permissions. That they can
No, we don't support no tool in Sidecar.
Yeah.
We do not run no tool in Sidecar. There are very specific endpoints.
Cool. Okay.
And yeah, no.
Great, thank you.
I appreciate your question, and we do not do that.
Chris?
So like you mentioned, it's very modular and stuff, but like, say we really want another tool endpoint for part of our migration to the sidecar. Is that just a contribution to add that? And we don't want to disable it. Is that kind of the idea?
Yeah, so internally, Sidecar uses Juice modules. So we went through the effort of making it very modular, so you have very well-defined modules like authentication, authorization modules, some endpoint, and you could contribute something that is specific for Node2 if you wanted to, yeah. Yeah.
Or you could build it internally on your own. Please don't do that, but yeah, you could have it turned on or off too. All of the endpoints are configured in Juice modules, so you could just not have that enabled if you didn't want it.
I do think like node tool is something that a lot of our like sidecars do provide.
We are trying to provide endpoints that do things similar to things that no tool does without running no tool.
But from a migration standpoint.
Yeah. I get it. That makes sense, and I would also love to suggest that if you need specific things that need to be done, let's add new endpoints that are a little bit more focused on those things.
Yeah.
But yeah, I get it. If you're trying to like move from your bespoke control plane to this, you may need to either live with both of them running for a while or have some new endpoint in Sidecar that have to think about how we deploy that in
Yeah.
particular.
I think the idea is to have yeah, the idea is to have bespoke endpoints that are like very well defined and kind of map to some existing functionality that you get through Node2, and you want to have like granular authorization story for each of those, because you don't want you want like a subset of users to do like some things in your cluster and like some other subset of users to do like something different. So that's kind of the idea.
Anything in API you want scope, single responsibility. At the same time, it's a trade-off. As no tool grows, you want your API space to also grow, but you want to control. So that's a trade-off there.
Go for it.
I might have missed it if you didn't cover it, but how like I know it's like you have the authentication but like if we do have a different, like totally different type of mechanism for authorization, like the portability of that is
Yeah,
very
very easy. Like you can configure your own authorization provider in the YAML.
Or if you have like something fronting your requests, you can always use the allow all authentication. So
One, I don't know, maybe how can it get the certificate, especially when it connects to the Cassandra cluster, you require that certificate, right? So where to put that certificate inside your the sidecar, the application, or?
so the clients will authenticate with their certificate that has an identity. So maybe we can go back to the slide. This one. Yeah, the clients will start the request to Sidecar with their certificate, client certificate, and in that certificate you'll have some identity like as a subject alternative name, something like this spiffy that we have as a sample, and then in the Cassandra table you will add an identity. So there's grammar to add identities that bind or map to a role in the Cassandra. So for example, if you were to do add identity and then this string and then map it to a specific role, when Sidecar server sees the identity, it will match that role and it will act as that role. So it will get the permissions from that role, and whatever you are trying to do, it will do an intersection and make sure you have the right permissioning for the action that you are trying to do.
Yes.
So I was wondering, so I saw you had like a Sidecar internal key space where you had like Sidecar specific like feature permissions and stuff. So the idea you can basically create a role that you wouldn't be able to use like with CQL, but you'd be able to use with like Sidecar features. And can you also do both directions? Like, can you have a role that can authenticate with Cassandra via CQL and then also do things with Sidecar?
Yes, it's flexible. Like right now, you can also use the default users that you create in the Cassandra database and map them, add these permissions to those roles. Or you can also create like analytic specific role and grant them permissions to analytic specific key space. So it's flexible.
Cool. That's awesome.
How does the deployment look? Is it like one per node or one per data center, or?
Yeah, that's a good question. It's gonna Sidecar right now it touches the file system that the Cassandra instance where the Cassandra instance is running. So it's a one-to-one mapping.
Okay.
But you could have, if you had more than one Cassandra instance in a single box, you could manage that with a single Cassandra instance.
Okay.
Is there any plans to provide API to register own endpoints and logic? Like we have a very weird in-house service registry. So to register my node, I will have to run another sidecar, or I can extend this one.
Yeah, I think you could always extend it. There's no specific plans to have that feature in Cassandra Sidecar, but something that can be extensible. Like I mentioned, it's very easy to like add a new module into the Sidecar, and it's very isolated to like specific feature. You can even toggle like on off these specific feature subsets.
Would you consider like having a UI front end part of the Sidecar project, or would that be considered like an orthogonal thing? I'm just kind of curious, like if there's an opportunity for that.
Yeah, yeah. I think that's something I think a lot about Sidecar having a UI where you can easily do things, but yeah, I think it's not something crazy. So I think it's
probably like further down the roadmap, if anything. Yeah.
There was also discussion to have CNN.
Oh, that'd be great, actually. Yeah.
Yeah.
there's a CEP around the new management API for Cassandra. Currently, I guess the sidecar is using JMX to interact with the database. I don't see anything in the roadmap about relying on that new management API rather than JMX. Do you have plans for this?
Yeah, I think that's one of the ideas is to eventually move everything to like virtual table management. But one of the deficiencies that we have is like if you are managing an instance and you disable binary, then you cannot manage that instance right now. So we still need JMX. So one of the things that we've been thinking about is having an admin, dedicated admin board or something in Cassandra where you can actually continue doing these management activities. So that's something that the CEP mentions, but it's out of the scope of the CEP. But I think Sidecar will need to have the ability to still be able to manage the instance, even if you disable binary.
Looks like that's all the questions. Thank you for attending the talk.